All right, let's go through how to find a function rule for this sequence. In the next section, in section 8.2, we actually focus on this exact same type of sequence right here, where all they keep doing is adding the same thing every time. And so, oh, also you might recognize this from homework as every other odd, but you know. Anyway, so in this sequence that you can tell, like they just keep adding 4 every time. So in a way, that a lot of people didn't like that recursive definition stuff, but in a way, it's the recursive definition that we notice first. Like, hey, you just keep adding 4. Anyway, but, you know, sadly, the easier thing to do isn't what you were asked to do. You were asked to find a rule where you could jump to any term in the sequence right away and not have to build it up one at a time. So that's the one where you start it with a sub n here. There are different ways to go about this one, and we'll talk about it a lot in the next section. One way would be to start with the initial value. So a sub 1 being 1. Here, let me make a table. I saw another teacher make tables for these, and it actually made a lot of sense that way. So, so your first term, when n is 1, your first term is 1. And then when n is 2, that would be this guy. You know, your second term is 5, which was really just that first value, your initial value of 1 plus a 4, right? And then your third term is 9, or sorry, your third term, yeah, is 9. And how'd you get the 9? Well, you added 4 twice to the first term. And so that would be your first term plus 2 4s. Anyway, and I could go back and be extra nerdy and say 1 4. And I could go back and say plus 0 4s. So this is one way to kind of like notice a pattern, is where you could just kind of say, okay, well, here's the rule, you know, for any nth term, you're starting with 1 and you're adding a bunch of 4s. And how many 4s? Well, when you're on the third term, you're adding 2 4s. When you're on the second term, you're adding 1 4. When you're on the first term, you're adding 0 4. So basically, you're adding n minus 1 4s. Cute, right? Anyway, so one way to write the rule would be to say 1 plus n minus 1 4s, which is just horribly unsimplified. But that is one way to write the rule. You could also simplify it and get a couple different versions of it. So let's see, if you multiply the 4 in and combine like terms, we'd get 4n, and then minus 4 plus 1 would be minus 3. So we will call it success if you got either of these, and definitely if you understood that t-table over there. Anyway, okay, so that would be the rule for the nth term. Now, see how though, like it wants you to stop at 49? So what we would probably need to do is add something about what n values should be used to start at 1, generate 159, and continue in that manner, but then stop at 49, since this is a finite sequence. So if we needed to know, I mean, you could probably figure it out, right? Like, what would you add to 1 to jump to 49? Well, you'd have to have added 48. How many 4s is that, right? That would be 12 4s. And so if you started at 1 and added 4 12 times, then what term is that? I claim it would be the 13th. So to say that you want to start at 1 and stop at 49, you could say n going from 1 to 2 to 3 and so on until you get to 13. And you could check and make sure that that would work. So like if you put 13 in to the rule, my first version here, 13 minus 1 would be 12 times 4 is 48. Add 1, you get 49. So that's super cool. If you put 13 into the second version, 4 times 13, 40, 52, take away 3 is 49, you know, so it works. Another way to figure out what term this is once you've got the rule written, you could just take 4n minus 3 or you know, take the way you've defined the rule, even if it's the unsimplified version. I like the simplified one for this, and say when do I get 49 out? And then just solve, like add 3 over, divide by 4, and you get n equals 13. Come on, that's adorable. Anyway, so the point is that if you have a finite sequence or series, then sooner or later you might need to know how to say which n values to use to generate that exact number or that exact list of numbers. And in this case, you'd need to use n values from 1 to 13. All right, now let's talk about how would you generate, how do we say this? How do we say add them together instead of just listing them? And that's actually going to be a pretty simple thing. It's just a matter of being told. If you've ever seen the Greek alphabet, there's a Greek character called sigma. Lowercase sigma looks like this, and it's used commonly in statistics, I believe. And uppercase sigma looks like this. And so we're going to use uppercase sigma because sigma, being kind of like Greek character S essentially, is the notation that we use for sums. And a series is just a list of numbers that would be generated by a sequence, but then you add them together or you sum them up. And what you do is you put the rule that you'd use to generate the numbers. So that's just the sequence rule that we found up above. So like 4n minus 3, for example. You put that inside sigma, and then what you do to say plug in 1, and then 2, and then 3, and then stop with plugging 13 in is you would say as n goes from 1 to 13. So this, my friends, is a function rule that would generate this series. Now, let's talk about if you see the sigma notation, how to kind of use it. Like if instead of making it up, if you're going to use it and you need to know, or like somebody's going to give it to you and you need to know what it means. So how do you use this? Well, you look at, so let me give you some vocabulary. So here's the rule for the sequence. Okay, so this part is the rule to generate the sequence of terms. The n in this case is called the index. The index. I is your lower bound. Sorry, 1 is your lower bound and 13 is your upper bound. So what you do if you're given this and you're asked to expand it is you start by plugging in that first number at the bottom there, your lower bound, into the rule. So you'd have 4 times 1 minus 3, which is 1. Then you bump that number up by 1, so you index it by 1. So the next number you'd plug in would be 2. 4 times 2 minus 3 would be 5. And so because we're using sigma notation, you'd know to put a plus sign there instead of a comma. Next thing you'd plug in after 2 would be 3, exactly. So 4 times 3 minus 3 would be 9. And you keep doing that until you get to this upper bound, that top number. That's telling you when to stop. You stop after you plug 13 in. So that would be 4 times 13, which is 52, take away 3, which is 49. There we go. All right, so hopefully at this point you feel comfortable with the idea. You're starting to get a little comfortable with how to write a function rule for a list of numbers or a sequence, and then how to use sigma notation to basically say that you want to add the numbers together as opposed to just listing them. All right, let's see. So let's check and see how you're doing. For example 6, I'm asking you to evaluate the sum as I goes from 3 to 5 of I cubed minus 3. A couple things before I turn you loose to see what you can do with this one on your own. This time the index is called I, which is a common name for the index since that starts with I. In this context, we do not mean the imaginary number, the square root of -1. You're just supposed to know to treat it kind of like we did with n in the last problem. The next thing I want to make sure you can do is read this and sound educated, because in life that actually matters. And so to read this, when you see the sigma, you would say the sum. When you see I equals 3, you would say as I goes from 3. When you see the 5, you say to 5, and then of, and then you read the rule off. I cubed minus 3, okay? So let's practice this. I know you're by yourself, but seriously, let's practice this. What do you say when you see this? The sum as I goes from 3 to 5 of I cubed minus 3. All right, now let's say it fast. The sum as I goes from 3 to 5 of I cubed minus 3. All right, hopefully you can sound educated And then not only that, but hopefully you actually are educated. We'll check and see in the next video how you did. Good luck.